Okay, good. We've been looking primarily at triangles lately. We already proved using this tessellation method what the triangle angle sum of any triangle is. What do all three angles of any triangle add up to? Yep, 180 degrees. So that's when we'll have three sides, and it's going to stand for a number of sides today. Okay, and the sum of the angles was 180 degrees. And remember with our tessellation, we took our one triangle and we color-coded the angles, but because I can't put it in color, I put the textures on here with polka dotted stripe, or the patterns, polka dot stripe, and solid. What? The worksheet? Welcome to it. Everyone just picked it up. Did you get crayons? Okay. Grab a couple bags of crayons. Here. Okay, so we have a triangle, and then we rotate it to make a tessellation. So when I rotate the triangle, did anything about the triangle change other than its direction is pointing? No. So I have this triangle and it's rotated. What type of shape do I get when I get two triangles? It's a parallelogram. How can we actually prove that the top is parallel to the bottom? Okay, you're really warm. And not only say we're going to use that one in just a minute, actually. Not only do they have the same slope, but each side is the same, but does the altitude or the height of the triangle change when I rotate it? No. So if I put a column holding up that side and a column holding up this side, those columns are the same length. The altitudes are the same length. So the top of the parallelogram is parallel to the base of the parallelogram, because the top and bottom are both the same distance apart from each other no matter where you are in the parallelogram. We can argue the same thing going the width of this triangle. Does the width of the triangle change when I flip it over? No. Okay, so the width of the triangle stays the same, so the right and left are also parallel. So this is in fact a parallelogram. All right, moving outside triangles, how many sides does our parallelogram have? 4. Okay. Now we're trying to discover the angle sum. Remember, one triangle sums to 180 degrees. And is 4. How many different angles are in a triangle? 3. So we can make a correction. Here's our solid angle, our striped angle, and a polka dot angle. That represents one triangle's worth of angles, right? We have another correction, or grouping. Here we have one of each of the 3, correct? So 2 groups. So we have one triangle of 180 degrees, one a parallelogram that consists of 2 triangles. What are the angles sum to? 360. So our sum is 360 degrees. Okay, over on the right, we have another 4-sided figure, and it's still 4, but it's a different type. It's not a parallelogram. What shape is it on the right-hand side? It's a trapezoid. So we have a trapezoid has 2 sides parallel and 2 sides not parallel. So now what we're actually looking for is the angle sum of they're called interior angles, but these interior angles have to be on the vertices. You can see some of the triangle markings, or angle markings, a couple of them are not actually on the corner of the trapezoid. Where do we have angle markings that we should not count because they're not on the vertices? Yeah, we're not going to count those because those aren't on the corner, right? So we're looking for groups of 3 angles that we know add to 180 degrees. Here's one group. We get one of each different pattern. Do we have any other groups? Right. Do we have any other groups? Are there any other groups? Yeah, yes or no answer, guys. No, because we don't count these ones on the bottom because they're not actually on the corner. So if we have 2 groups, each group sums 180 degrees, what's the sum of our interior angles of the trapezoid, which is also a 4-sided polynomial? Also 360 degrees. So even when we change the polynomial, because it's a 4-sided, another word for 4-sided is a quadrilateral, it still sums to 360 degrees. Now, if you look below, I've added more sides. Someone besides Braden, because you answered the last example. What shape is this? What shape is it, Javier? Hexagon. How many sides are in a hexagon? 6. So n equals 6. And again, we are trying to solve they're called interior angles, but they need to be on the outside of the hexagon, not fitting in the middle. So which angles should we not be counting up? Yeah, all these ones in the middle. You're just ignoring those. Would you go through and stand up when you think you know the sum of the interior angles of a hexagon? That's a very bright shirt. Make sure you have a degree. Okay, so find the groups of 3 like you're doing over there. Yep. Make sure you have a degree. Okay, so you circle them. Now each one is 180 degrees. So how many degrees do you have? Good. Good. Audrey? Okay, Aaron, what did you get? How do we know it's 720 degrees? You guys can go home and see. Oh, there are 2 ways to go about it. One, you noticed, we have a trapezoid on top, which we already found out was 360, right? And the trapezoid on the bottom, so 360 and 360 makes 720. That's one way to do it. Or you can find your groups like we did before, and how many groups do you end up having? 4. We know each group represents a triangle, so we take 180 and do what with the 4 to get 720? What is it? Multiply. So you take your number of groups and multiply by 180. So 180 times 4 also is 720. So we're going to figure out the theorem by looking at the pattern. So follow along carefully. My triangle's falling. Sorry. Okay. It has to do with the number of sides. So everyone look up here, please. The triangle n was 3. We had one group of angles, which summed to 180. With a quadrilateral, n is 4, how many groups do we have? 2. When we have n is 6, how many groups do we have? 4. Anyone know this pattern yet? The triangle, n was 3. We had one group. When n was 4, we have 2 groups. And then 6, we have 4 groups. What's the pattern? N minus 2. Triangle has 3 sides, subtract 2, you get 1 group. Quadrilateral has 4 sides, subtract 2, you get 2 groups. Hexagon has 6 sides, subtract 2, you get 4 groups. And then once you know the number of groups, how do you find the measurement of the angles? The sum. Multiply. Okay, that's the theorem. Polygon angle sum theorem. You take n minus 2, notice this is in parentheses because you have to do that first. So you do parentheses first, and then you times by 180 degrees. You can do it for any polygon. I stopped at a hexagon. We could have gone to, what comes out of a hexagon? What's a 7-sided called? Hept. Yep, E-T-P-T, hept. Heptagon. What's an 8-sided? Octagon, 9-sided. Pentagon 5. Nonagon. 10 is decagon. What about 11? Octagon? They trying to make Spanish with polygons or something? What's an 11-sided shape called? That's actually correct. What's a 12-sided shape called? Polygon. I think you might actually be able to call it 12-sided like dodecagon. But basically after 10, you start just saying the number gone. So we're going to try using the formula. Everyone, someone always talks about thinking like they're like, yeah, this can't be right, but it's actually correct. We're going to try to find the sum of the interior angles. First, let's do a 32gon. What happens when we have more and more sides? What does that shape start looking like? What? Starts looking like a circle. It won't ever get perfectly to a circle, because the sides are always technically still linear. But as you add more and more sides, it starts looking more and more like a circle. I'm just going to take this off. This is falling off. Okay, so apply the formula. What would the angle measurement be? The sum of the angles. Make sure you have a degree sign. Take the number of sides, subtract 2, and that tells you how many groups you have. Groups of 3 triangle angles, and times by 180. What'd you get? You have a degree sign on that? Yeah. Okay, so you take 32, subtract 2 in parentheses. You need an extra 0. Then you write 32, subtract 2 in parentheses, and then times by 180. Okay, this is what your work should look like. You should actually write down your work on your paper. 32, what do we subtract? 2, and then we times by what? 180. So you get 30 times 180, which is 5. Yep. Okay, one sec. I'm going to give you 2 more to try on your own. Stand up when you think you have both, and put your hands over your pencil. Make sure you have a degree sign. Stand up when you think you know both. And you need degree signs and you need your work on your paper. Yeah, I just said that on the last one. You write on your work. Good. Okay, so write down the work. Yep. Okay. Okay, good job. Okay, good. What's the first one? 3,960. You should write down your work. 24 minus 2 times 180 is 22 times 180, which is 3,960. If you want credit on your homework, you need to write down your work. Okay? Otherwise, I'll think you just copied someone's homework. 18 gone, we do 18 minus 2 times 180, which is 16 times 180. What does the last one come out to? Good. And what's the D word when you say at the end of that? Degrees. Okay? So let's define the sum of the angles. At the end of this worksheet, we're going to do, if you know the sum, how do you find each individual angle if they are congruent? We'll do that at the very, very end. Okay, equilateral polygon. What does the word equilateral mean? All sides are equal. Do we already know a shape that could be equilateral? Oh, okay. Yeah, you jumped already. What about three-sided? Equilateral triangle, right? So all sides congruent. So some of those would be like an equilateral triangle. You already found the first side of it was a square. Can we have a five-sided? What's a five-sided called? Pentagon. Like in Washington, D.C., they have a pentagon. We can go in the hexagon. It starts getting harder to draw as you add more sides. What does equiangular mean? All angles are equal, congruent. All angles congruent. Do we have a three-sided polygon that has all angles congruent? What is it, Raji? Who knows of what three-sided polygon has all angles congruent? What kind of triangle? Equilateral triangle. All angles of an equilateral triangle are how much? 60 degrees. Equilateral triangle are all 60 degrees. Let's move up to a four-sided quadrilateral. There are many four-sided quadrilaterals that have all equal angles. A square. Does it have to only be a square? We could also do a rectangle. Are squares also rectangles? Are all rectangles squares? No. Okay. So a regular polygon is both of those together. Regular polygons are equilateral and it has to be both equiangular. Okay. What polygons do we know about? Some of them we already have on the board. They're both equilateral and equiangular. Squares. Any others? It has to be an equilateral triangle. Because all three are 60 degrees. Can we have a pentagon that is both equilateral and equiangular? Yeah, if you draw it carefully. Okay. And we can find, on the next page, we'll solve and find out what the measurement of each of those angles would have to be in order for that to work. Okay, so if you get a regular polygon, that word regular should flag to you that means it has to be equilateral and equiangular. Okay? The word regular tells you equilateral and equiangular. Go ahead and flip it over. This is going to need a crayon. I love pick a crayon color. Now, increase the tessellation. Are you glad you didn't have to draw that again? Huh. And we're looking for a specific polynomial, a specific parallelogram. That's the word I want. In order to look at exterior angle sum theorem. So you find this parallelogram in the middle row that still has triangles all the way around it, and take a crayon and highlight it really dark or really highlight so it pops off your page and you can see it. Don't color it all the way in, just color the edges, the sides. The front page is all about interior angle sum. Now we're going to look at exterior angle sum. Exterior angles come from extending one side. Or it's saying each side one direction. That's what I say. Saying each side one direction. So I'm going to take the top and extend it only to the left. You don't extend it both left and right. You extend it only in one direction. Then you take the left side and extend it down. It will start looking like a pinwheel. You know those things you go on? Nice spin. Okay, and the bottom I'm going to extend to the right. And the right hand side I'm going to extend up. Okay, so you only have to go like halfway. That's far enough. Okay. So with your crayon, do those extensions. So each side is only extended in one direction. Okay, and this creates exterior angles. So we're looking for the sum of the exterior angles. On the top, what shapes or what patterns do we have for the top exterior angle? And polka dotted and the stripe. Let's look at the next one. What's the angle for the exterior angle over here? Solid. Oh, so this creates 180 degrees. Goes together. And let's look at this exterior angle. Polka dotted and striped. What's the other one? Solid. So we have two groups of 180 degrees. So the exterior angle sum would have to be how much, Veronica? We have two groups of 180 degrees. 360. Good. So the polygon exterior angle sum theorem is for any, this actually works for any polygons, the exterior angles sum to 360 degrees. I didn't do it. We can like make this tessellation larger, actually look at a hexagon and extend them, and we also get 360 degrees. Okay, now I'm saying on the other side when we drew the pentagon, that was a regular pentagon, meaning all the sides and, sorry, get to the right chapter here. All the sides and angles have to be congruent. So, kind of like a Chrysler sign. This is a regular pentagon with all the sides and angles, equilateral and equiangular. Let's find out what the angle sum is, the interior angle sum. How do we do that again? Brian, how do we find the interior angle sum? Okay. Good. So how many sides do we have? So we take 5, subtract 2, multiply by 180 degrees. As you have, you know, the angle sum for any pentagon. What's the angle sum for any pentagon? It could be given any five-sided. Raise your hand when you know the sum. You know it either? What'd you get? 111 degrees, 540 degrees. Now that would be for any five-sided shape or polygon. But if we have a regular pentagon, regular means it has to be equilateral and equiangular. We're going to find each angle measurement. Find the measure of each angle. Well, if we know that they sum to 580 degrees, how can we find the measurement of each angle, knowing that it's a regular pentagon? Divide by what, Sammy? Why do we know to divide by 5? Because there's 5 angles and we knew they were all congruent, so that means we can divide them evenly. So we would take a 540 and divide by 5, and what do you get? 108 degrees. That's the measure of each angle. So essentially, the formula for this is n minus 2 times 180, because you have to know the angle sum. Then you divide by, divide by 5. What if we had an octagon? Divide by 8. If we had a 100-gon, we divide by 100. So what should I put below here? N. I should put N. The number of sides, N. This is the formula to find the measure of each angle of any regular polygon. Sorry. I am reading the wrong section of my book today. This helps you find the measure of each angle of a regular polygon. Okay? Any questions about that? You can go both ways. You can find the sum of all angles, and you can find the measurement of each individual angle if you know that's a regular polygon. And all exterior angles of any polygon add up to how much? The exterior on the outside. They all add up to 360. If it was a triangle, it add up to 360. If it was a quadrilateral, it add up to 360. Okay. A couple weeks ago, a famous actor passed away. Do you know who that is? This applies to your lesson, I promise. Tom Lawrence was like a little while ago, a month or so, right? Who was it? Spock! Spock passed away. I don't remember his real name. The song says it, and I recognize it. Spock passed away from Star Trek. For Christmas, my family, my dad really likes Star Trek. Like, he really likes the original Star Trek. And so we don't watch Christmas movies during Christmas break. We would start on Christmas Day our Christmas Star Trek marathon of all movies in order, starting with Star Trek the Motion Picture. In order. Through all of the newest ones. We have all of them. I can't remember if it's 11 or 12 now. Movies. So we have a marathon. My mom usually sleeps through all of it. But anyway, so this applies to math, I promise. What does Spock always say?
Live long and prosper.
Yep.
Live long and prosper. Live long and prosper.
Okay. So with his hands, right? This is broken. It was broken and funky and they do this with their hands. Live long and prosper. Well, when he passed away, my in remembrance of Spock. And our dad's, he really likes Star Trek. So my sister in Boise, Idaho, sent this picture to him of her kids, my niece and nephews, doing Live Long and Prosper in remembrance of them. They couldn't quite hold their fingers that way, so she taped them. And little baby, Daniel got really poorly. He's too small to do it. So he's playing with the tape, Live Long and Prosper. Well, Spock today is going to help us remember things about parallelograms. 2 things about sides, 2 things about angles, and 1 about angle bisectors, the diagonals. Okay? So, on your notes, oops, okay, nope, it's going to start playing. How do I cancel this? Because it started playing yesterday, that was weird. Okay, on your notes, this will call some of them, but we're going to fill in parallelogram Spock. So I'm going to pass out parallelogram Spock. You're going to staple it to the corner of your notes. Okay? You pass the stapler over to them back there. So. Okay, staple to the corner of the properties of parallelograms I just gave you. Good staple. And pass stapler around quickly. I don't know if I have any more staples. That could be a problem. Oh, staples! Oh, that's a lot of... Yep, so the newest one I gave. Whoa. This came from the teacher who had this room before me, so I don't know what sheet they're in. Put that one in. That'll work. Okay, pass the staplers around. Here's another one with some more staples in it. There you go. Okay, while you go through the staplers, let's read the 5 check boxes here on without that on your desk while you lunch break. What's one thing about parallelograms? If you tell me the algorithm goes to read the first checkbox. Okay, Chris. One. The first box. If the quadrilateral is a parallelogram and its opposite sides are congruent. Well, let's look at a tessellation picture and see if that's actually true. Here's the parallelogram. We already proved that it was parallel. And, shoot, so we just read the sides one? Yeah. If I take my triangle, look what's on the outside. In this case, in my picture, it's the side created by the straight angle and the solid angle. And I flip it, does the side of the triangle change by flipping it? Does the side of the triangle change, or are those congruent? If not, it doesn't change. Same with the base. The base here, if I flip it, becomes the top. Does that change just by flipping it? No. So this side is congruent to this side. This side is congruent to this side. That's what that checkbox says. Okay, Chris picks someone to read the second checkbox. That's enough. Go ahead. Oh, you have film on the second one. Opposite angles are congruent. Let's see if that holds true for our picture. The bottom left is a blue angle, opposite from it. On the other side, what do we get? Is it a blue angle? Are they congruent? Yeah. What about these ones? Is this congruent? So this guy? Yeah. Okay, so I already read the one the angle or the diagonals. The diagonals bisect each other. So there's one diagonal. Here's another diagonal. I need to make sure you're looking this way once in a while. I know you have a really awkward seat, but a bisect means this piece would be congruent to that piece. And this piece would be congruent to that piece. They're going to bisect each other right at each other's midpoints. Okay, try to pick someone to read the fourth checkbox. Okay, the fourth checkbox, second from the bottom. Okay, that's just the converse of the one I just read. The first one says if it's a parallelogram, then the diagonals bisect each other. And that's just saying the reverse. If the diagonals bisect each other, then it is a parallelogram. Okay, I'll pick someone for the last checkbox. Okay. So sometimes the parallelograms are not typically over. Sometimes they're at 90-degree angles. So if you find that these diagonals are perfectly congruent to each other, then it has to be a rectangle. Okay, so on your parallelogram spot, we're going to list some things coming out of the fingers. There he is. Okay, first, we just went over two things about, the sides. If you want to write that in your crayon, you can, or you can just write it darkly in pencil. Sides. Two things about sides, two things about angles, one about diagonals. What's one thing we know about the sides of parallelograms? The word parallelogram says one thing in it already. Opposite sides are congruent and opposite sides are parallel. That's the two. So we have two fingers, so we're going to be writing two things coming out of fingers. So we have two pairs of opposite, and it's OPP, opposite parallel sides. Two pairs of opposite, so that's what the OPP is, parallel sides. Top and bottom are parallel, right and left are parallel. And we have two pairs of opposite, OPP, congruent sides. Top and bottom are also congruent, and right and left are also congruent, as well as being parallel. So two pairs of opposite congruent sides and two pairs of opposite parallel sides. Okay, now there are two things about angles. The other two fingers write angles. Okay. What are two things we know about the angles? There's one of them listed on your paper. Opposite angles. Opposite angles are congruent. So we have two pairs of opposite congruent angles. I'm just going to draw an angle symbol. Two pairs of opposite congruent angles. Okay, so The other one comes from knowing that if this side is parallel to this side, what's this line that cuts through them called? Transversal. The other comes from the same side angles. 1, 2, 3 different angles on the interior. How much do these three add up to? 180 degrees. And then on the interior, what's the name for the interior angles that add up to 180 degrees? Consecutive interior angles, CIA. So they also have CIA angles here, CIA angles here, CIA angles here. There are 4 sets. So we have CIA angles are supplementary. CIA angles are supplementary. CIA angles are supplementary. They'll only be congruent if it's actually a rectangle. Okay, so 2 things about sides. Opposite sides and 2 pairs of opposite parallel sides and 2 pairs of opposite congruent sides. 2 things about angles. Opposite angles are congruent. We have 2 pairs of those. And we have CIA angles. There's 4 pairs, groups, I guess we call them groups of CIA angles. And one thing about diagonals. What do diagonals of any parallelogram do to each other? Bisect each other. So there's one thing about diagonals. Diagonals bisect each other. Diagonals bisect each other. Okay? If you flip your note paper over to the back, we're going to just, using this knowledge, find this inside. We're not going to do that foolproof at the bottom. Now, we're going to take number 2 and number 5, and maybe one on number 3. Okay, number 2. Find the values of the variables. And it tells you it's a parallelogram, so we use all properties from parallelogram stock. And part A, we have angles marked. So we should probably think about what are the 2 things about angles. Karen, can you tell me one thing about parallelogram angles? And they have to be where? So opposite of each other. Opposite congruent angles. And then they also have CIA angles. These happen to be the opposite angles. The one's on the bottom right, the other's on the top left. So if opposite angles are congruent to each other, how can we find B? So they're equal to each other. 6B minus 10 equals 120. And solve for B. Hold up the value of B in the air, fingers in the air. You know the value of B. Oh wait, this one's a decimal. Kidding. That's going to be a little hard to hold up. Sorry, we'll do that in a minute. We add 10 and divide by 6. It doesn't come out evenly. Now, no one in the corrections didn't say round. So you can tell me how to write this decimal precisely without rounding. Right? 21, let's see it right there. Okay. 21.66 repeating or just 6 repeating. Put a repeating bar over 6. The calculator ends on the string with a 7 because the next number is a 6. It just ran out of room. So it rounded the last letter up, the last number up, because the next number would have been a 6. Yeah, this would be 21. The cool thing about repeating fractions is you can always put it over a 9, which is 21 and 2/3. You could write it like that, yeah. Okay, let's look at B. Let's find what we're going to do, I think, with Z, because we're on a short day, we're running out of time. How do we find Z? So they're equal to each other, because you know something about the diagonals. Diagonals, what's the word? Right on parallelogram spot. Diagonals bisect each other. So we'll have 2 congruent pieces. 6z plus 1 equals 4z plus, that's a 9, by the way. That's a 9. 9. Use an arrow and you know the value of z. Yeah, a couple. Brian, did you find y maybe by chance? It should be 4. Should be 4. Could you subtract your smaller z? And then you add, or actually we're going to subtract 1 over. So 2z equals 8, so z has to equal 4. Okay, and c is a different one. What's the margins on the sides? So we have two things on sides. Opposite sides are parallel, and opposite sides are also what? Congruent. Yeah, and how would we find the value of x on part C? Which ones equal to each other? Well, we have two sets. We can tell these ones equal to each other or these ones. Yeah. Because you could do it either way, right? But this one looks like less work. So if you top and bottom say those equal to each other, that's going to less work than the right and left. Right and left have binomial on both sides. So if you add 3.5, what do we get for x? 22. Okay, really quickly we'll get at 5. These are just yes or no if you have enough information, and your tick marks didn't really copy, so put your mark there, double angle, single angle, double arc, and tick marks here. On the first one, part A, is there enough information to say that this is actually a parallelogram? Why or why not? The only marking I see is we have one bisector. One segment being bisected. That's the only marking I see. Is that enough to just know that one of the diagonals is bisected? No. You need to know that both of the angles are bisected. So this one is no. You need to know that both of the diagonals are bisected. Okay, the last two, we have two pairs of opposite congruent angles, or we have two pairs of opposite congruent sides. Is that enough information to know that they're actually parallelograms? If we have two pairs? Yes, that's a yes. Okay, your homework comes from volume 2 in your book. It's 3 different sections, but there's 5 problems on each one of them. 595, 603, 614. All of these you're going to do 3 through 21, multiples of 3. So that means there's only 7 problems on each one. What does multiple of 3 mean? 3, 6, 9, and it's divisible by 3, you should do it. There should be 7 on each section. 3, 6, 9, 12, 15, 18, 21. Those are the problems you should do.